video is about measures of dispersion or measures of variation. When we talk about dispersion, we're basically talking about the spread or the variability of the data. So we know how to find the mean already. This talks about how spread out the data is from the mean. In some cases, it's not bad to have a large variation in data, but in other cases it is. As an example, if you are Coca-Cola and you're selling a 2-liter bottle of Coke, then you want the variation of the volume, the amount of Coke in there, to be very closely spread around the mean. In other words, you don't want your data with a large standard or a deviation. There's two types of dispersion that we're going to talk about. The range, which you take the difference between the highest value and the lowest value. And then the standard deviation, which takes into much more detail about the spread of the data. And we'll show a step-by-step process for how to calculate that. So let's take a look at the range. The range doesn't give much information about the data. It just tells you what the high data is, and the low value for data. So let's take a look at an example. Let's say we have to find the range for the following data. So we have this data listed, and we know for the range we need the highest value, which in this case looks like it's 122. And we're going to subtract from it the lowest value, which appears to be 118. So my range is going to be 122 minus 118. And my range turns out to be 4. It doesn't tell me a lot about the data. It gives me a very simple description of how spread the data is. So now let's talk about how we're going to calculate the standard deviation. Okay? So we're going to come up with a step-by-step method for calculating the standard deviation. The first step is find the mean. Okay, we already know how to do that. The second step is complete a table where you have the data values in the first column, so we'll call those X's. Then the second column is going to be the data minus the mean, or X minus X bar. And the third column, you're going to take the value from the previous column and square it. So that's our second step. The third step is take all the values in the last column and add them up. Then you're going to divide by n minus 1, where n is the number of data points. Then you're going to take the square root of the answer you got from step 4, and this is your answer. Let's look at it in terms of an equation. So we're going to let S stand for standard deviation, and here we have the formula for calculating standard deviation. So here's my X minus X bar squared. This sigma means sum. That's a notation for summing up everything that's listed there. And then I divide by the number of data items minus 1 and take my square root. So it's all my steps listed right in one nice equation. So now what we're going to do is we're going to take that same data set and we're going to find the standard deviation. This is the same data we used for the range. So my first step is find the mean. So that means I add them all up and divide by how many. So there's 6. So I'm going to add those all up and divide by 6. And for my mean, I get 120. So now I'm going to go ahead and make that table as described. So I'm going to do my data values in X, X minus the mean, X bar, and then I'm going to take that difference and I'm going to square it. So let's go ahead and let's put all my data values. Now we know that X bar equals 120. So in here I'm going to have, in this case it's going to be 120 minus 120 equals 0. Here it would be 118 minus 120. Well, that's going to give me -2. We can continue in that fashion. So now for my next column, I'm going to take each of these values and square them. Well, 0 squared is 0. Now, -2 squared, how many negatives do I have? Well, this exponent tells me how many, and that's even, so my answer is going to be 4. And -1 squared is 1. So now my next step is to add these all up. So I have 8. So now I'm going to take that value, 10, I'm going to divide by n minus 1. Well, n was 6. So 10 divided by 5 is 2. So my standard deviation equals the square root of 2, or 1.414. Now what does this tell me? This tells me that if I had a number line and here was x bar, okay, which we know was 120, it tells me that one standard deviation away, 1s, is where I would have 121.4. And one standard deviation this way would be 118.6. So what it tells me is the smaller this number, the closer the data is grouped. And that is standard deviation.